Hello. So this is kind of the last segment in our tutorial today, but what we wanted to do was kind of go over several questions, kind of frequently asked questions that we commonly get from DeepSpeed users, especially new users. So with that, I will, so we have 3 people on the team here that are on the call right now, but I'm going to act essentially as the user asking these questions. So the first question we have is for Samyam. So when does 0 show sort of the best memory improvements?
Yeah, so most of the memory improvement from 0 is coming from reducing the amount of memory required to store the model states. So these are your parameters, gradients, and optimizer states. So 0 shows improvement if these model states are what is causing the model memory bottleneck during the training. So this is generally true for larger models. So in general, you can think of it as if you're doing mixed precision training and you're using an optimizer like Atom, if you have 1 billion parameters, then your total memory footprint is going to be 16 billion. So you just take the number of parameters in billion and multiply that by 16. That gives you the amount of memory footprint. So if your model states itself is consuming 16 gigabytes of memory, that's quite a lot. So when you use the 0 optimizer, it can reduce that by a factor of 8. So that 16 goes down to 2. So basically in these cases where you are trying to train a large model with lots of parameters and your memory footprint is large due to these model states, that's when 0 really shows improvement.
Excellent, excellent. Thank you. So one more 0 question is, does 0 have like a huge performance penalty, or like aren't you doing sort of additional communication or something like that?
Yeah, so that seems to be the common misconception, that we are doing a lot more communication than default data parallelism. We are doing a different type of communication than data parallelism, but we are not doing more communication. So in fact, the 8x memory improvement that I talked about earlier, that is absolutely free. There is absolutely no increase in communication when you use 0 to get the reduction in memory. We do have an additional optimization in 0 that is not currently in DeepSpeed that allows us to decrease the memory even further and has some communication overhead that can impact performance. But currently, the 0 in DeepSpeed that gives us up to 8x memory reduction has no communication overhead, and so it doesn't impact performance. And if anything, since you're reducing the amount of memory required to train the model, you're actually able to increase the batch size. So you'll end up actually seeing a performance boost than a performance degradation. Yeah.
That's excellent. That's excellent. Cool. So one sort of switching gears a little bit, a question relating to BERT, and this is for Tunji, is a lot of people have noticed that like our BERT record, for example, of pre-training and all of our BERT kind of code in the DeepSpeed examples repo sort of assumes that you have access to this like BNORIC data or like this sort of specific data set that you used for training. Since we didn't, like the DeepSpeed folks haven't publicly released that data, like how can I actually train this model using your code?
That's a great question, and the good news is you don't need the BNORIC format anymore. Recently, we just made some changes that allows you to use NVIDIA's dataset. So NVIDIA has a publicly available dataset for pre-training BERT, which includes the Wikipedia and the book corpus data. And we just added support for it. If you look into the README section of our Bing BERT example in the DeepSpeed examples repo, you would see instructions for using that, and it works right out of the box. You don't need to make much changes. We provide you the scripts and the configuration files, so you can simply just launch them and run them. And as long as you have the data set set up, and NVIDIA has very nice instructions on how to prepare the data set. And so once you have that all set up, then you're good to go. And you can train with our DeepSpeed model. You can use our custom transformer kernels. You can use all of the niceties of DeepSpeed while training with the NVIDIA dataset.
Excellent. That's great. One other question is, when I'm training with DeepSpeed, sometimes I notice at the very beginning of my training that I get these strange overflow warnings that are sort of in all caps lock or all caps saying overflow, overflow. Should I be concerned about those, or what's that all about?
Yeah, you really shouldn't be concerned about those. Overflow basically comes from the fact that you're doing the mixed precision training. In other words, you're using FP16 to train in scenarios where sometimes you might require a full 32-bit floating point value. And so what the solution that is typically used is to do a loss scaling of your FP16 values. And so sometimes, and because it's really hard to know what the right loss scale value is, so you start with a value that may not fit, and when it doesn't fit, then the model, the training infrastructure detects that and throws out an overflow and sort of basically skips that example, and it lowers the loss scaling. So basically it's adapting and adjusting the loss scaling so that eventually you wouldn't see the overflows anymore. So seeing overflows at the beginning of your training is nothing to worry about. And if you're really worried about it, you can start with a lower loss scale value. And in DeepSpeed, we do provide you the ability to configure a starting loss scale value, which is much lower, and would basically get rid of the overflows. So it's not something to be concerned about. It's just a part of the regular mixed precision training.
Excellent. Cool. So one last question, and I'll field this myself, I guess, is so I've heard of this feature from NVIDIA Apex called AMP. So they call it automatic mixed precision. So DeepSpeed supports FP16 and mixed precision, and Apex does. Like, how do these sort of relate? So the answer to that, to answer my own question, is essentially the way that DeepSpeed works initially when we first released it is by doing something kind of similar to AMP in terms of what Tanji was just talking about with loss scaling, but it was kind of targeted originally at just sort of one kind of mixed precision mode where just about everything is an FP16 or half precision. So Apex, or the NVIDIA folks, released this package called AMP, which kind of lets you switch between modes. So there's like a sort of partial FP16 and FP32 sort of mixed combination that works well with certain models. And what we recently have released is the ability for DeepSpeed to kind of switch the back end of DeepSpeed to support these different AMP modes. So urge you to check out our website and the DeepSpeed configuration JSON config, and I'll show you kind of how to use that and turn that on if you're interested in that feature. Cool. So with that, I think we'll conclude. Thanks, you guys. Thanks for everybody listening, and bye.
Bye.
Thank you. Bye-bye.
Use DeepSpeed.
Happy deep speeding.
Yay.
Yeah.
All right, cool. Did Jeff drop out?
It's still recording.
Yeah.
And I was gonna cut that out.
Yeah, we can cut that out, I guess. But Jeff, I guess he also killed the call.
Oh, we have to leave. Okay. Oh boy, how are we gonna?
Okay. All right. All right. Talk to you later, Tanji. Bye.